is rusting of iron. See, you have iron articles in your house, and when you put it into the oven sometimes, and you have usually see in the rainy season that the iron gets rusting. Powder form convert. So this is called rusting. If you leave a piece of iron in an oven for some time, it acquires a film of bluish brownish substance. This substance is called rust, and the process is called rusting. As you can see in the figure 6.2, when you leave some iron articles in an oven like this, so you can see that after some months or some times, it gets started rusting. So that is rusting of iron. Iron gates of parks, farmland, iron benches kept in the lawns and gardens. Almost everywhere, articles of iron kept in an open gets rust. At home, you must have seen the shawls and spade getting rust when exposed to the atmosphere for some time. When you keep these things exposed, means fully for some times into the atmosphere, so when it comes to the contact with the atmospheric hydrogen, then it started rusting. Even it comes in the contact with the water even also contains the oxygen, therefore it started rusting. In the kitchen, a wet iron pan, that is dot, often gets rusted if left in that state for some time. Rust is not iron. It is different from the iron on which it gets deposited. Actually, do you know what happened? When you leave the wet pan as it is for some time in the kitchen, it started rusting. Actually, what do we think? That the iron powder is just falling off, but it is not actually the iron. It is some other substance. What is that other substance? Let's read and understand. We understand this by performing some of the activities. Let us consider a few more changes where new substances are formed. Let's perform activity 6.6 and understand. But before we perform an activity, what is the carefulness that we must have to adopt? Is written over here. It is dangerous to look for a long time at the burning magnesium ribbon. See, that is a magnesium ribbon. If you will see it continuously to be burning, then it is not okay for you, it is harmful for you. The teacher should advise children not to stare at burning ribbon. Now let's perform an activity. Get a small piece of thin strip of a ribbon of a magnesium. Clean its tip with the sandpaper. Bring a tip near the candle flame. It burns with a brilliant white light. When it completely burns, it leaves behind a powdery ash. Does the ash look like the magnesium ribbon? No. See, what is the experiment is about? What is the activity is about? That take a magnesium ribbon. Now clean its tip in the most upper part, and then you apply some sand powder on it, and then what to do? Take a candle and just keep up to that candle flame. When it started burning and the ash is produced, gas means dark. Ash is produced, and is that ash is of magnesium? Of course, no. The change can be represented by the equation. See, the change can be represented by the equation. Mg means magnesium plus oxygen that is available into the atmosphere becomes, the arrow means becomes magnesium oxide. That is the new substance, magnesium oxide. The equation here are different from those mathematics. So, as we know that equation means the formula and whatever etc. But that is different from that math. That is, it has a you add some cheese on it. So it gets come into contact with each other, it gets mixed, and what becomes cheesy pizza. Similarly, magnesium plus oxygen is to magnesium oxide. Then magnesium oxide plus water, magnesium hydroxide MgOH2. As you have already learned in chapter 5, magnesium hydroxide is a base. So magnesium oxide is a new substance formed by burning of the magnesium. Magnesium hydroxide is another new substance formed by mixing magnesium oxide with water. See, when you mix magnesium plus oxygen, it becomes magnesium oxide. But when you add this magnesium oxide and water, then it becomes magnesium hydroxide. So this one is also the chemical change. So now, if you don't understand, then let us perform another activity to clear your concept about the chemical changes. See, dissolve about a teaspoonful of copper sulfate, that is blue white. This is the copper sulfate that is available in the laboratory. In about half cup of water in a glass tumbler or a beaker. Add onion. So this is not important. You can take a beaker or a glass. The simple thing is take a glass, add some copper sulfate in it. That's it. Add a few drops of dilute sulfuric acid. Now add dilute sulfuric acid. Sulfuric acid to solution. You should get a blue colored solution. Have a small sample of the solution in a test tube or a small glass bottle. Save a small sample of solution in a test tube or a small glass of water. Now see, separate them into the four different glass. See, the full filled glass should be added into the another glass. So now equal solution. Both are in blue in color. See, right now you can see the green color, but earlier they both had a blue in color. Drop a nail means key. Drop a nail or a U-shaped blade into the remaining solution. Wait for a half an hour or so. Observe the color of the solution. Compare it with the color of the sample solution saved separately. Do you see any change in the color of the solution? Yes, the color of the solution become green. See, what is that? Take a copper sulfate solution mixed with water, add some dilute sulfuric acid in it. Colors become blue. Now make a half of two glass. In a first glass, the blue color vital, let it be as it is. And in a second glass, add the blade in it. And when after easing is, you can see the easing is here. And see the bubbles of the gas coming out. Pass this gas through the freshly prepared lime water, as you can see in figure 6.5. Now pass this into the solution of lime water. What happened to the lime water? The change in the test tube is as follows. The lime water's color has changed. So here you can write that the vinegar that is acidic plus baking soda that is sodium hydrogen carbonate, it becomes carbon dioxide plus other substance. The reaction between the carbon dioxide and lime water is as follows. So reaction you can write like this. Turn the page and you can see the reaction. And what happens when the carbon dioxide plus lime water? What is carbon dioxide? Vinegar and baking soda becomes carbon dioxide. So when you add lime water in it, so carbon dioxide plus lime water become calcium carbonate plus water gets separated. When a carbon dioxide is passed through the lime water, calcium carbonate is formed. The new substance is formed, and that is calcium carbonate, which makes the lime water milky. What happens? The lime water become milky. Generally, the lime water is not white in color. It is just like a simple water color. But when you add this carbon dioxide, it turns into milky. The turning of lime water into milky is a standard test of carbon dioxide. You will use it in a chapter 10 to show that the air we breathe out in a rich in a carbon dioxide. Even from this experiment, you can conclude that the carbon dioxide is present in the vinegar and post-that baking soda. The presence of carbon dioxide can be seen like this. When you add some lime water into that water becomes milky. That means that water contains carbon dioxide. Simple. In activity 6.6 to 6.8, you saw that in each change, one or two new substances are formed. In activity 6.6, the S was new substance formed when the magnesium was burnt in the air. Activity 6.7, the reaction of copper sulfate with the iron produces a new sulfate and copper. Iron sulfate and copper. Both of these are new substances. Copper was deposited on the shaving blade of iron. In activity 6.8, vinegar and baking soda together produce carbon dioxide, which turned lime water milky. Can you name the new substance formed in this reaction? That is soda. Simple. See, you have got in this 6.2, you have got from 3 activities. In all the 3 activities, 6.6, 6.7 and 6.8. Let me conclude the 6.8. Activity 6.8. You can see that the change occurring in the mixing vinegar plus baking soda is chemical reaction. Why it is chemical reaction? Because it produces a new substance. So from all this activity, one thing that you know is that after mixing two substances, the new substance is formed. So it means that when you add two substances together, and if the new substance is formed, then it means that the reaction is a chemical reaction. A change in which one or more new substances are formed is called chemical change. A chemical change is called chemical reaction. Chemical change are very important in our life. All new substances are formed as a result of chemical changes. See, what is the use of chemical changes? See, we are humans and we always need a new things. So new thing is formed by the chemical changes. So this is important. As a result of chemical changes, for example, the digestion of food in our body, ripening of fruit. See, ripening of fruit is a chemical change, yes? Formation of grapes, etc. happen due to the series of the chemical changes. A medicine is like it produces a unnecessary gas, harmful gas. We don't need that. So this is unnecessarily changed. When food gets spoiled, it produces a foul smell, bad smell. Foul smell means bad smell. Shall we call this change as a chemical change? Think over it. Yes, it is a chemical change. You must have noticed that a slice of apple acquires a brown color if it is not consumed immediately. See, if you cut an apple, if you leave it for some time into the open atmosphere, it started to become brown. Why? Because oxygen gets mixed with it, and it converted that yellow or a white color apple into the brown. So this is also the chemical change. If you have not seen this change in a color, cut the fresh slice of apple and keep it away for some time. Repeat the same activity with the slice of potato, brinjal. The change in a color in this case is due to the formation of new substances. Are not these changes chemical changes? Yeah, some are chemical changes whereas some are not. In chapter 5, you neutralized an acid with base. Is the neutralize a chemical changes? Is it possible to neutralize a chemical changes? Yes, in some cases it is there. Now the protective shield. In a blue box, some of the careful things are given. So let's read and understand. You must have heard of an ozone layer in our atmosphere. Yes, there is an ozone layer in our atmosphere. See guys, the sun rays cannot directly reach to us. It has to pass so many layers, and after, see, sun is a main source of energy. It produces very much of heat, and it produces very much of rays. But the rays are so harmful. If they directly touch to your skin can be damaged. So he has to pass so many layers in the earth, and one of the most protective layer is ozone layer. Yes, ozone layer saves us from sun rays that reach directly to our body, that heavy and a very harmful UV ultraviolet rays. But do you know, nowadays the ozone layers become weak. Yes, it becomes big hole into the ozone layer, and the rays directly reach to the earth. That's why in some place the fire explosion happen automatically. In the summer time, the fire explosion in the chemical factories happens automatically. It protects us from the harmful ultraviolet radiation which comes from the sun. Ozone absorbs this radiation and breaks down into oxygen. Oxygen is different from ozone. Can you call the breaking down of ozone is a chemical change? If the ultraviolet radiation were not absorbed by ozone, it would reach to the earth's surface and cause harm to us and other life forms. Even it harms to the plant also. Plants started burning and it became dry. Ozone acts as a natural shield against the radiation. See, this is our protective shield. Ozone layer is our protective shield. So be careful. Never ever burn unnecessary things. Just plant more trees. Save your environment and save yourself. So what do you learn from this point? You have learned that the change in which one or more new substances are formed are the physical change. Sorry, it's a chemical change. When a new substance is formed, is a chemical change. Yes. Example rusting of iron. When we leave iron in open for some times, it acquires brownish substance. This substance is called rust. So, and this process is called rusting. We also have performed the three main activities: 6.6, 6.7, and 6.8. From 6.6 and all the activities, we have learned that the new substance is formed each and every time, and that's why it is called a chemical reaction. So here the 6.2 is